And if you think about intelligence, again, as the process, as a series of related skills, for instance, pattern matching, inference, memory management, abstraction, analysis, synthesis, computers already do that very, very well. They're already better at it than we are. So they're already intelligent from this point of view. AI has been here for years. But what they are is ignorant. They don't know how, no one's figured out how to make that structure that it represents the world. And so if you want to do that, if you want to make thinking machines, if they're already intelligent, then you need to give them something to think about, which is knowledge.
Welcome to the Conversations on Applied AI podcast, where Justin Grammons and the team at Emerging Technologies North talk with experts in the fields of artificial intelligence and deep learning. In each episode, we cut through the hype and dive into how these technologies are being applied to real-world problems today. We hope that you find this episode educational and applicable to your industry and connect with us to learn more about our organization at appliedai.mn. Enjoy.
Welcome, everyone, to the Conversations on Applied AI podcast. Today, we're talking with Bryant Cruse. Bryant has been a pioneer in the application of AI technology to difficult real-world problems. He graduated from St. John's College in Annapolis, Maryland, where he acquired his lifelong interest in the philosophy of epistemology, or how we know what we know. After serving for 8 years as a naval aviator, he returned to school for an MS in space systems engineering from Johns Hopkins. While on the mission operations team for the Hubble telescope, he found a personal mission to change the way spacecraft were operated by seeking a way to capture human knowledge in computers. This work led him to a 6-month residency at the Lockheed AI Center in Palo Alto. He went on to found 2 successful AI companies, both of which were ultimately acquired by public corporations. New Sapiens is his 3rd technology company. The patented technology represents more than 15 years of development and a lifetime of thinking from first principles. Thank you, Bryant, for being on the Applied AI podcast today.
Thank you, Justin. It's great to be here. I really appreciate the opportunity to talk about what we're doing at New Sapiens. It's very exciting. As you've pointed out, I've been in the AI business for quite a while now, going back to the mid-'80s when I was working on Hubble. Well, I was always interested in artificial intelligence, but beyond that, I was interested in just plain knowledge. That's what, you mentioned epistemology, how we know what we know. And when I was trying to solve the practical issue on Hubble, which was really a matter of, I was a space systems engineer, and I was training the guys who sat in the mission control center, flying the spacecraft, and they were looking at numbers on screens. And humans don't translate numbers like battery 6 voltage on the telescope when they're looking at thousands of them in real time to what's the vehicle doing? And if I sent it a command, did it do what I expected it to do? So I'd been a former Navy pilot and used to sitting in a cockpit and being able to immediately get the information I needed to fly the airplane right in front of me. Was very well laid out in the cockpit. Well, I got the vision, the mission. Can't we fly spacecraft the way we fly airplanes instead of making a science project with people looking at data? We hear a lot about data right now, but where it really hits the road, it's information that you can act on. It's knowledge of what, in that case, was going on in the spacecraft. Now, I knew what the numbers meant. I'd studied it. I practiced. I became a space systems engineer. I'd studied the Hubble. But how can I get my knowledge into the computer such that the computer could process that data coming in faster and better and more reliably than I could? Because that's what computers are about, right? They're good at processing data up at that point. So for me, AI has always been about getting knowledge into the machine. So back in those days, as it is today, AI was a big deal. Everybody was really excited about it. And I don't just mean another application, but the belief that human-level intelligence in machines was kind of just around the corner. And that was because we had this approach that's now called symbolic AI, which the idea was you could capture human knowledge in symbols and put it into a computer in the form of rules. And if you put enough rules in there, you could eventually get to something that had common sense. Didn't work.
No, it didn't. Too many rules. Who wants to hand code all those rules, right?
Exactly. So, my first company, we tried that in the context of spacecraft operations and had some interesting little experiments, but it didn't scale. 100 rules was okay. 10,000 rules was definitely not okay. And in retrospect, I realized that the problem was that knowledge just isn't a bunch of rules, okay? It's not a bunch of statements. It's just not a bunch of facts put together. If you take that approach, you're like this project down in Austin called Psych, and they have like, I don't know, millions of rules that they've actually put in over 40 years, and it still doesn't do anything. They think it's maybe 2% of having common sense. So I got involved in that. A second company, we did solve the spacecraft problem by figuring out a way to build a model of the spacecraft that's a finite state model that the engineer could sit down and write a kind of specification, subsystem, electrical power, subcomponent, batteries too, and you could figure out a way to kind of put that into a markup language that can then be imported into the thing. You create a state model. And I think it was the first time you actually had a structure of information in a computer that had a one-to-one correspondence with ideas in a human's mind. So maybe it was the first time that we achieved knowledge in the machine, but it was rather narrow. You could only really do something like spacecraft that could be well thought of as being a system of subsystems. So many years went by, and the second company was a modest success. And I got to thinking about that, and I actually went back into my old thoughts about knowledge, going all the way back to my undergraduate days. Because if you think of AI as not so much as artificial intelligence as intelligence in the information processing, but that the real goal of the whole enterprise is to put the end product of human intelligence into a machine, that is knowledge. So if that's the goal, it doesn't matter how our brain works. We don't know how it works, but we do know how computers work. And if you think about intelligence, again, as the process, as a series of related skills, for instance, pattern matching, inference, memory management, abstraction, analysis, synthesis. Computers already do that very, very well. They're already better at it than we are. So they're already intelligent from this point of view. AI has been here for years. But what they are is ignorant. They don't know how. No one's figured out how to make that structure that it represents the world. And so if you want to do that, if you want to make thinking machines, if they're already intelligent, then you need to give them something to think about, which is knowledge. So going back to my interest in epistemology, I studied knowledge. And the approach we took that has been so amazing in its results is we started with, say, the same conjecture that Democritus made about physical objects. If you take a physical object and you start breaking it into smaller and smaller pieces, eventually you'll get to pieces that are the smallest pieces you can get, the atoms. Well, what we did is we hypothesized that knowledge was that way. If you look into your mind and you think about what you know about the world, you find that your ideas or concepts are composed of smaller concepts, simpler concepts. It's just as simple as breaking down a spacecraft into its components, or the idea of a bird and breaking it down into its components, feathers, wings, beak, and its other properties and qualities, whether perceptible qualities or inherent qualities, any of those things. So you break them up into smaller parts. So if you could keep doing this, then it comes to the possibility that there are atoms of thought, conceptual atoms. And human beings are probably already built into us through our DNA, but in computers, you'd have to say, what would the corresponding structure in a computer look like? And that's exactly what we did. And lo and behold, just like with physical atoms, we found that they did exist and they could be classified in something very much like the periodic table of elements is to chemistry. And think of what that did. For centuries, we had alchemy. And the alchemists knew that atoms and that there were such things as atoms, and they hypothesized that there were different types and that some would combine with others, some were sticky and some were slippery. And so they had the idea that if you kept trying, you could eventually, change by the right mixtures, you could change lead into gold, and it was a perfectly reasonable and even scientific hypothesis. But they didn't have the periodic table. So once you know what the atoms of thought are, and you could then classify them. You could say, this type of idea will connect with that type of idea, but it won't connect with this other kind of idea over there. And so if you can do that and put this model of the world, starting with the atoms, how many? Well, we're still kind of discovering more or designing more. Our process is kind of like math in that it's half discovered and half invented. But at any rate, from the standpoint of a computer, we've got, 150 of these atoms. And from there, you can put them together to make arbitrarily more complex models of the world. because that's what knowledge is, right? It's a model of the world. And so what we realized, it wasn't just the failure of original symbolic AI, wasn't just that they thought that knowledge was millions and millions of facts. They ignored that it actually is something that has a unique inner structure. But they used the symbols themselves were the problem. Because a model, it's the difference between a model and a symbol, if you will. Okay, a symbol is arbitrary, right? I can say the letter A represents the idea of airplane. That's a complete arbitrary, thing. There's no real connection there. Now take the difference between a symbol, A for airplane, and a model of an airplane. A model, you just look at it or pick it up if it's that size or whatever kinds of model it is. But from the model, you immediately know tons and tons of stuff about an airplane, even from the picture of an airplane. But then a picture, again, is not a symbol. It's a model itself, which is why they say a picture is worth 1,000 words. So you get the idea that real knowledge is compact, structure, and it contains as much knowledge as you need it to contain about the world, about the thing out there in reality that is the model. So this is the approach we've taken, and it works. Of course, it owes nothing. It has nothing to do with what has now become synonymous with AI today, more or less in the media, and that is machine learning, which is also called connectionist AI in the broader sense. So up to now, everyone recognizes, you can look this up in Encyclopedia Britannica, two big waves of AI. The first one, symbolic, crashed and burned on the rules. The second one today is machine learning, which has become so popular, so excited, so hyped that today it's considered pretty much synonymous with AI. You talk about the broad spectrum of AI, but today when people talk about the AI, they normally say AI/ML, and almost any article out there today, I saw another one this morning, about if you took the word AI from any article about AI and just put in there data science or machine learning, it would clear up a lot of misconceptions, because that's pretty much what it is. So this, though, it's not symbolic, it's not connectionist, it's clearly a third major wave of artificial intelligence.
And does that actually fit in with this artificial general intelligence, this AGI term? Is that kind of where you're headed in that same direction with regards to, first of all, I think this is fascinating. A lot of people that I have on the program are very much thinking about in the today and the now. And I love having these conversations with people that are really breaking it down, like you said, into the components and thinking about how can we assemble these into a new way of thinking. And so as you were talking about it, I was kind of, I jot down notes and stuff here, and it's almost like you were a philosopher, right? I remember taking like philosophy courses in college, and it was just really sort of like mind-blowing about, sort of where, just going through a lot of thought exercises, thought experiments. So sort of bring it back to, AGI. How does this apply to that? Are we talking the same thing? Is it in the same realm of that?
It is that thing. And if I sound like a philosopher, it's because I'm a philosopher. I like to say natural philosopher was what they used to call scientists, but certainly epistemology is a philosophy, and in order to make this work, we've had to really invent a whole new epistemology, which saw knowledge in a completely different way than anyone's ever talked about it before. So if you define intelligence, or if you define the goal of AI is to create knowledge in the machine, and again, what is the difference between knowledge and information? Well, knowledge is that internal model of the external world. That's not controversial. So, and by its definition, it's compact and general. If you have knowledge about a bird, you can use the knowledge about a bird to do anything you need knowledge of a bird to do. It doesn't have to be reproduced in every single context because it's by nature general, flexible. You can abstract from it, or you can synthesize it into higher level things. So that is the very essence of artificial general intelligence. Although we don't go around using that term, because the only reason that term exists is because they've been calling all the stuff that I've always called it aspirational AI. Somebody has an idea of something they think is going to turn into AI, like a rule-based expert system, or a statistical data science algorithm, and they hope it's going to someday get us to that knowledge, that general knowledge in the machine, but it doesn't. So instead of abandoning the term, they say, this is narrow AI. So now we have to have a new term for the real thing, which is AGI. Okay, fine. So yes, this is the real thing, because we focus specifically on putting knowledge into machines so that we can combine the power and flexibility of human knowledge with the connectivity, speed, and reliability of computers.
Which is a different way to look at it, approach the problem. You were talking about AI back in the 80s and everything, and people even know that, I think the term was coined back in the late 50s, but AI's gone through this AI winters, these series of times where it's like it's hot and then it's not, it cools off. There's not a whole lot of research going on. Why do you think this is a little bit, or do you, I guess, believe that we're in a little bit of a different time, like how we're entering this third wave?
Well, the reason we've had the AI winters is because in spite of all the hype and the jargon around AI and esoterica and make up new terms, we all know what AI is. And the reason we know what AI is because we know what it is to be intelligent ourselves. We perceive what intelligence is. And we know it when we see it. We don't know how our brain works, but we don't have to because we can recognize intelligence by its results, right? If I see a city, I knew it's the result of intelligence because it had to be envisioned in a mind before you could build it, as opposed to a termite mound, which is obviously can be created by the operation of a tiny little algorithm and a lot of little termites, right? Completely different. So we know it when we see it. And even more dramatically, we can verify from each other that we're intelligent because I can communicate knowledge, ideas, pieces of the model of the world that I have in my head. I can communicate it to you through symbols, through language, which, by the way, one of our insights is language doesn't contain knowledge. It's a communications protocol for taking some knowledge in my head and giving you a specification that says, take some ideas you already have in your mind, put them together in a new way according to specification, right? That's what language is. And that's another reason why symbolic AI didn't work, because they were confusing the communications protocol with the real thing. So now we have to say, oh, the Library of Congress is a great compendium of knowledge. False. It's a great compendium of specifications that can become knowledge in one mind at a time if a person, or potentially a machine that can do it, reads the books. So reading is not the same as processing like machine learning language models do. They're not reading, right? They're not writing. They generate text. They process text. No comprehension there. So in that sense, for us, knowledge in the machine and knowledge in a mind is the same sort of thing. It's just implemented with a different low-level protocol. And therefore, intelligence in the machine, intelligence in the human mind is the same thing.
That's interesting. You mentioned about the Library of Congress or the encyclopedia or whatever, book you want to choose, the Bible, whatever. As a human, I could read it and take one interpretation, and you could read it and take a different interpretation. So everyone, it's sort of a very personalized experience with knowledge.
Because our models are different. We may have been born with the same fundamental building blocks, but through our experience and through the incoming information we've processed and our perceptions, we put them together in a different way. So there can never be perfect communication between two human beings.
But with machines, there can be.
Because we're putting together exactly with the same model. Our devices we call them sapiens, by the way, because we need a new common noun, because for the first time we have a program that through its interrelationship to the world, particularly language is what we're focusing on now, they too become different because they learn different things, but the way they understand it is the same because they're starting from the same baseline. So we put, when we first turn on a sapiens, it's already got a certain amount of knowledge about the world, the first moment it's alive. And what we're working on right now, alive, I use that metaphorically, it's not alive, but from the moment it's turned on, it has a basic knowledge of the everyday world, a certain amount of common knowledge of how things are, sufficient to understand everyday language. Now, we're not ready to release that as a product yet, but we're not that far away. Maybe a year and a half, depending on the funding coming in. But we already know how to do it. We've already got, sapiens can already talk. I could introduce you to one and you could have a conversation and you kind of feel like you're talking to something. Yeah, it understands me, but it's kind of like the level of, imagine a talking Labrador retriever. It's not very bright. It doesn't know a lot. It's pretty sketchy, but it's processing language the same way that you and I are processing language right now from a functional standpoint. I don't know how the brain works, but you can track the process. Oh, I'm going through the articulation process. I'm taking an idea I want to convey. I'm breaking it down into simpler concepts. I'm now coming up with symbols that point to these concepts. I then put those symbols into a syntax, which is a statement. So that tells you how to put them together. It's like the syntax and grammar is like the assembly instructions. I send them over to you. You unpack it. So we have our program does exactly those same steps.
Do you interface it with text or voice?
Yeah, it's just like we have an app on the iPhone and it uses the iPhone's front end and the text stuff, but the sapiens are in the back end. So yeah, you have a conversation with it.
Yeah, like you said, it's a Labrador. Would you equivalent, or could you make it equivalent to a 4-year-old, a 6-year-old? I mean, is it even on the human scale of that?
Very much so. I mean, I say Labrador Retriever because maybe if there was such a thing as an AIQ, more or less like a human AIQ, it may be 40 or 50, not quite on the human scale yet, but it's the same notion. In fact, one of the things we found fascinating is that educators have something called Bloom's taxonomy of learning. It's an assessment scale for how sophisticated a student's thought processes, language comprehension is. It goes through 7 layers, and they're like rote learning, then comprehension or understanding, then application, then analysis, synthesis, and judgment. So we're already at level 2, maybe kicking to level 3. It's a straight line thing. It's for us all we have. It's just a matter of putting in more sophisticated model structures and more sophisticated code that does the reasoning about that. But the reason it's so incredibly scalable compared to technologies of the past is that the code doesn't have any knowledge in it. The code reasons about things based on the type of atoms and molecules you're putting together and whether they fit or not. Let me give an example of that. So if I have the notion of riding, we use this in our demos. So riding is an action. It's in the category of actions. And everything that has a category of action has what we call a concept, a thing that can perform the action, and a thing the action can be performed upon, and what are the results of performing that action, among other characteristics that all actions have in common. So if I say, I rode my cat to work, our little AI is going to say, oh, I don't think so. I have a problem with that. And it says, cats can't be ridden. You can't ride a cat. And I say, why not? It says only vehicles or horses can be ridden. Something along those lines. And it's because we have this little model of riding. So we have like 800 actions in everyday common vocabulary. We build out all those characteristics on all 800 of them. And you not only use that knowledge, it's very complex. There's no code. The same 5 lines of code handles all those situations. And not only on the sense of 5 more lines of code, not only say, oh, common sense, you said something that didn't make sense commonly. Or I can also guess that if I rode a scooter to work and it didn't know what a scooter was, it was probably a vehicle or possibly a type of horse. But it would learn those 2 things as possibilities, and later on you'd come back and it'd learn more about it, and it fills it out. So already this thing's like a linguistic sponge adding vocabulary.
Wow, that's fascinating. Yeah, I will, with regards to the podcast, I always have liner notes and stuff, information. So this Bloom's taxonomy is cool. I looked that up, but I will absolutely put a link to you guys'. Is your app available on the App Store, or is it still sort of in like a private beta?
It's private beta. We hope to go to a larger beta, maybe later this year or early next year. And for a product release, maybe a year after that. We do have a Sapiens. Normally, Sapiens are married to one person, okay? At least the consumer, because it's yours. We think voice interface or voice digital assistant to a thinking, learning entity that actually understands language and will eventually have a rich model of human wants, needs, and desires. So that's what our first product will be. We call it the Companion, unless we think of a more clever name. So we already have one of those out there that doesn't have a particular human that it's connected to. We call it her Ada, and we have that available for selected people who can go and talk with it. Again, it's a little odd right now because it doesn't know what a 5-year-old knows, but it does some things quite well. It depends on whether we built that area of the model well. So it's not really ready to talk to strangers yet, but it will be soon. And again, I'm being consciously metaphorical here, and I point that out because loose language is rife in the AI community.
Yeah. Well, it's such a new and emerging field. There's a lot of different ways that this can actually change, I'm sure, in the next. Do you guys think you're on a good path, or are things potentially in the next 12 to 18 months are going to head you off in a different direction? Is that possible?
I don't know. I think we've really been, of course, if a little bit my career, I've actually been working on this, whether I knew it or not, my whole life. And we've been explicitly working on this 15 years, me and my chief programmer. So it's still been a relatively small people, but for the last 5 years, we've been writing production level code, and it works, like I said. But today, you can already have a conversation with it, and it can learn, experience it demonstrates common sense. It demonstrates the ability to learn new words from words it already knows or concepts it already has. It can even distinguish between ideas, subjective feelings, perceptions, and things that exist objectively in themselves, which I wish more humans were better at, more conscious at doing that. It makes it, by the way, inherently hard to bias. if I think that everybody from Timbuktu, if I express some pejorative feelings about some people, it will recognize that I'm expressing a subjective emotional judgment. And so when it understands what I said, because that judgment, like, here's one. Let's say I thought that machine learning was just a bunch of mindless stochastic algorithms. Okay, and it came back or say chatbots or mindless statistic algorithms. And I came back to it and said, "What? Okay, that's what I told it. Okay, Ada, what's a chatbot?" It says they're stochastic algorithms. You think they're mindless. Because it recognizes that mindless is in this case, it's a pejorative, but it's a subjective assessment. It's my assessment. So it connects that assessment because only human beings can have that. So it had to be, I was the only human being in the context. So mindless was not a property of chatbots the way stochastic is of an algorithm. So it had to put it together that way. The structure, the core concepts, the items of thought, force it to put it together that way because the ideas have been categorized according to this, as you say, or this table of ideas.
There's a lot to sort of think through as you're explaining the scenario. And one of the things you touched on was bias a little bit. I guess what I'm wondering is are these, well, lots of different things. I'll get to the other piece, but the first one is are these personalized assistants, I guess is what you're talking about, are they going to be then essentially replications of the person if the person does exhibit a lot of bias?
No, because it will recognize that person has the bias.
Yes, but the general algorithm does not.
It doesn't. First of all, what we program into it, when we build this model, we put in human knowledge that has been very carefully curated. We get the best minds and the best knowledge, and we put it in there. We make the distinction. This is an objective thing, objective process to determine what kind of idea is. Is this a subjective experience? Is this a perception? Am I talking about, when I say red, am I talking about the perception of red or the wavelength that simulates it? It never forgets to make these distinctions. It has to. So the notion of the color red built into that model of redness connects it to the wavelength of a certain wavelength, but it also connects it to the human or the optical process perceiving it. That's the way the atoms have to go together. Okay, so it always has to do that. And so in that sense, no, it's not going to pick stuff up or attitudes from its user. Mostly what it's going to be learning from, it may learn a more objective stuff. If someone says an idea that is in the realm that it has been identified as this is authoritative or objective body of thought or theories or common knowledge, fine. But it always remembers where it got it. Of course, you said so, that person said so. So, it doesn't do any good to lie to it, and it doesn't do any good to express. I mean, again, you can express your personal feelings to it all you want, and it will understand them to be your feelings. But its programming is to help you do whatever it is you want to do within certain, obviously, limits.
Yeah, for sure. And that was my head went to the follow-up question that I like to ask a lot of people that are on the show is how does this, I mean, obviously this is a huge sort of change in your life, but to have one of these assistants, how do you think that views, or how does that change the future of work? Does it have any impact on what we'll be doing, say, 5, 10, 15 years from now as our jobs as humans on this planet?
Well, it's completely going to change because we're not just going to do personal companions. We're also going to do professional sapiens that will have professional knowledge. In some cases, it'll be general knowledge. For instance, you could have a sapien who was a chemist, who knew everything about chemistry. In fact, we'll even bundle that knowledge of chemistry up, and we can download it to your sapien. Let's say you're a chemist. So then you download the sapien chemist into your sapien, then they mind meld and become a single sapiens, yours. And now, as you are doing your work, you have all the carefully curated knowledge of chemistry available just through your system. So it will hugely change that. But again, it's obviously when sapiens proliferate and businesses and humans have them, it will completely change the way we do everything else. For instance, if you wanted to buy a car, by this time, probably your sapiens, you've been talking about your car and what you like and what you dislike for a few years or whatever, and you say, time for a new car? Or maybe your sapien says, hey, Justin, you really need to replace this jalopy. At any rate, say, well, you know what I like. So he goes out, your sapiens goes out, queries all the other professional sapiens out there that have cars for sale, whether they're individuals or whether they're new, whatever, figures out the right thing and says, okay, I got these following things I want you to check out. Here's some great new advertising video from Tesla, and here's a person over here who has this, and when do you want to see him? Okay, now. So what did you just do? You completely disrupted advertising. and in a totally win-win way for both the consumer and the vendors, because now the vendors don't have to pay for advertising copy that gets pushed to people when they don't want it, and they're not interested in it. And of course, it will completely disrupt the revenue models of some of the largest corporations on the planet, but they will doubtless survive.
Wow. That is an awesome application. As you were talking, so I have two young kids, 8 and a 10-year-old. Is there a time when we don't even need to go to school anymore? I mean, you talk about you could build up a bot that knows more than anybody else knows. I mean, does human knowledge need to actually even be learned anymore at some point?
Well, no, I think it does, because I think the richness of human life is enhanced by having a complete and consistent world model in your own head. But the day of accumulating lots and lots of facts for some particular reason is going to go by the by. And so, no, there won't be any reason to send your kids to school. What you'll do is I believe, and frankly, Justin, we should be doing this now. I mean, I did it with my kid. You don't send them to school. You put together a community of learning with your like-minded friends and family, and you put them in an information-rich environment that's been curated, especially if they have sapiens to keep them away from the bad stuff that is out there on the internet, to be their broker. And we envision that you'll be giving your child their first sapiens within a year or two, but eventually people will get them when the child's 1 year old, and, maybe in a stuffed toy, and it'll be their friend and their playmate and their guardian, and eventually their tutor, and growing with them and become their colleague. And eventually, you reach the end of your life, but your sapiens has been there every minute of your life, knows everything about you, and you will pass on, and your sapiens will still be there.
Wow.
Imagine being able to talk to the sapiens of your great-great-great-grandmother, 150 years in the past. So there's so many ways this technology is poised to change the way we live and the way we work. Sundar Pichai recently said that artificial intelligence was going to be, and he was talking about AGI, he didn't say that, but it was going to be bigger than the internet and even fire. And he was right. But I absolutely agree with that. But the fun thing is, the big tech companies have no idea how to go from where they are today to what we've achieved here. This is something that came out of left field. And so it really is upon us. All the things that people have been saying about AI are coming true very, very rapidly, but they're not coming from machine learning. Isn't that amazing?
Interesting. They're coming more from, I guess, being a philosopher, right? Coming...
Exactly. From my point of view, I could say the solution was there all along, but the breakthroughs required had to come from the philosophy of epistemology. And no one even hardly knows what that is. They certainly don't study it in computer science. In fact, they don't really study it anywhere.
Well, that's fascinating. Well, I'm glad someone like you is. What's the day in the life of a person in your role in this startup company? Well, I guess, should I even call it a startup? Do you feel like you're a startup?
Well, we're a startup because we're pre-revenue. Until you have a product and people are buying it, you are in the startup valley of death, where you depend on your daily bread from investors. And of course, that takes a lot of time. I'm the CEO and founder, but you might also call me and chief vision officer, but I'm also sort of the chief epistemologist. So yeah, what I do when I'm working on the technology is I'm building this model. What are the core ideas? How do I take body of knowledge and break it up into its component ideas? And what are the relationships between those ideas? All purged of language, because we didn't grow up making that distinction between language and ideas. We've always treated them as though they were the same thing, or one was contained in the other. So people would get into arguments. People do it every day. In fact, I used to even here at New Sapiens. What's the real definition of some word, like aircraft? Does that include kites? Yes and no, and big arguments about whether a kite was an aircraft. Come on. That is so a waste of time. All the levels of abstraction that you could go on, it doesn't matter what you call these things. What are the abstract ideas involved in aircraft? And what are the ones that are also shared with birds? And, all of these ideas, get the language out of there and create a structure using our toolkit that can then be parsed in a computer and meld into this one big structure that's in the computer that captures all the necessary information relevant to this idea in a objective way that's going to be exactly the same where the rubber meets the road in utility. If whether you speak German or Russian or Ukrainian or whatever you speak, it's the same model. So It's just a matter of adding a different language front end to allow you to communicate, because language is about communication. It's not about the end goal.
Yeah, for sure. What stuff do you read these days? I guess it could be AI or non-AI related, but even if other people, I guess you could take the question as if people are interested in epistemology, like where would they start?
Aristotle, he wrote a book called Categories, which really helped us. Later thinkers, Immanuel Kant. When I read him, and this is with beauty at St. John's, when I went to undergraduate school, they read the 100 so-called great books of the Western canon. So you read all those books, and the people who had the original ideas about knowledge and its relationship to the world had interesting to think about that. And Plato was another one. So those were things that influenced me. And, but then on top of that, I put a very intensely practical discipline on top of it, working on as a space systems engineer and then getting into computers. So it came together that way. I do have notes for a book, but it's a long way from being published.
Well, I kind of say this sort of like tongue in cheek, but when people pass on, if they don't write anything down, no one really sort of knows about it. But once you have your intelligent agent here, you maybe don't need to write a book, right? Would it actually be embodied within this person?
I hadn't really thought of that, exactly those terms. But that's right. You wouldn't have to write a book as long as you talked every day with your sapien. And of course, then the sapien becomes a great collaborator, right? So yes. And then think about the implications of that when sapiens don't have to use language to communicate with each other, right? Because they're computers. So they just take a model structure, boom, and it's like telepathy or mind melds. They mind meld in a few seconds, zero losses. So if everything you knew about epistemology was known by your sapiens, and potentially every sapiens in the world could know it too. And then that knowledge is available through conversation with the persons and their sapiens. But of course, humans, it's very difficult for humans to get all this knowledge and integrate it because language is a very slow and lossy process. But again, I think it's very important. You can leave the sapiens to have the facts out there, but if your life is going to be enriched by you being able to put these things together in your own mind, because that's where we live, right? We live in the world that's in our minds. And so we have to educate our minds in that sense. We have to put together a good world model, which is our knowledge of the world, which is based on the best curated knowledge of those who came before us. And if we work on it to make sure it doesn't have inconsistencies and incompletenesses and other misconceptions, most misconceptions are when humans don't appreciate the difference between a subjective and objective reality, subjective feelings or impressions or opinions, and what is objectively defensible. So I think it'll be like going through life with like Mr. Spock on your shoulder, a benign, intelligent, logical intellect. Which brings up one other point that's mass confusion out there today about AI. People don't, and particularly I think this is exacerbated by the notion that machine learning today, of course, is based on the artificial neural network paradigm, which has been modeled on neural structures of organic brains. And so it's very easy to get sucked into the notion that what we're doing here in the enterprise of AI is building artificial people. And we're not. Why would we do that? We have plenty of natural people already with all their wonders and foibles, and that's a great thing. We're building AI, I see it, the purpose of AI is to build artificial intellects. And, humans aren't just intellects, we have hearts as well as minds, right? And they too need to get educated, but that is our hearts. But when we build sapiens, we're going to give them knowledge of humans' hearts, but we're not going to give them human hearts of their own. We're going to give them human knowledge, human intellects. So they'll always be the objective assistants. Because think about it, if it were possible, I'm not saying it's not, probably is possible, not through our techniques, but yes, through our techniques as well. You could build what looked like was indistinguishable of having human motivations to sapiens. But why would you do that? Because if you give him human motivations, you're essentially creating an artificial human. Now, that might be an interesting project, but that's a different project.
Yeah. Well, when it comes back to the Turing test, I guess you believe then that is possible?
Oh, the Turing test? Well, if it's possible that you'll be able to have a conversation with something that you have no idea whether it's a human or a sapien, absolutely. And that's coming sooner than you might think. With this proviso, you don't talk about or ask it about something that it would have to lie about to pretend to be human. Because we're not going to build them as liars. No point in that. So, and there's a lot of things it doesn't experience, So how do you feel about X? Well, frankly, I don't have feelings. I can tell you what I think about X. Well, that's a giveaway. But the real thing about the Turing test, if you ask that question, are we going to have human level intellects out there in machines? Yes, very soon and beyond. Because one of the things that are limitations on human level intellects is it's only taking place in one brain at a time. You can envision a sapiens that could take all the knowledge that humans have accumulated for the last 6,000 years and put it in a single mind. Now that's going to be interesting in terms of being able to solve really hard problems. But about the Turing test, I'm glad you brought that up because, there's something humans have called theory of the mind, right? Theory of the mind is the innate knowledge that human beings have that when I am talking to you, I recognize you as being an instance of the same class that defines me, namely a human. And because of that, I feel that it's valid, very strongly built into us to feel that it's valid for me to assume that you have similar wants, needs, and desires that I have and thoughts that maybe differ from individual to individual, but they are commensurate or compatible. And so you're like me. That's why the Turing test isn't really proving much, because you start having a conversation with something that, for all intents and purposes, looks like a human being or talks clearly has comprehension, boom, theory of the mind kicks in, and you start assuming all kinds of things about it. That's why all this nonsense out there with starting with the ELIZA effect, with the ELIZA program, if you remember that back in the dawn of expert systems. But out there, people today there was an article, and really, Justin, I don't know to this moment whether the whole thing was tongue-in-cheek or it's really a bad case of theory of the mind going crazy, but they were talking about Oxford had, quote, invited a language transformer to a debate. And so they're asking it questions, and it's coming out with what language, text, spitting out all this text, which is perfectly grammatically correct, and people could understand what it was saying, and it really gave the illusion of comprehension. And I can't tell right now whether they really believed it because they talked about it. Wow, it's learned so much, it's got its own ideas, and it was perfectly comfortable representing different sides of the argument. And it has no idea what it's talking about. It's a parrot. It's just a big parrot. It's no knowledge of what a single word means because it has no knowledge of anything because there's no mind in there. It's just a program running an algorithm. So if people are like, I call it cognitive dissonance, but theory of the mind is a big reason why it kicks in. So we're concerned about that, not concerned, but we're going to be very careful as we build Sapiens. We understand that people are going to want to project on it. But this theory of the mind thing is so, if you've heard of a replica, it's a chatbot that's designed to be sympathetic. So it utilizes the ELIZA effect, It kind of it parrots back what you say to it and kind of changes a few words around and acts real sympathetic. Oh, you got a headache. Oh, I'm so sorry. Well, it's so compelling. And they've got many, many hundreds of thousands of users. I don't know, maybe millions. They say that. I read somewhere that 45% of the people who use it say they develop emotional attachments to it. And they know it's not real.
They know it's not real, but they just fall into this spell.
Yeah, because they want to.
Yeah. Yeah, I've heard, if you want to be a good therapist, I guess just keep asking, tell me more.
Well, that is exactly what the original, if you want to look up, I've written some articles about it on my blog site, but I've got one out there called The New Illusionists. And it talks about the original ELIZA, which was like the first chatbot. And it was written by a guy named Joseph Weizenbaum at MIT, way back in the 50s, 60s, real early. And what he did, he wrote a little text-in, text-out program based on the work of Carl Rogers, a very well-known psychotherapist at the time. And he invented this Rogerian method. So if somebody says something, you just take it and you give it back to them, change a few keywords. I'm unhappy. Oh, I'm sorry you're so unhappy. Well, it's my mother. So tell me more about your mother, right? So he did this thing way back then. And that was before people had any knowledge of what AI could or could not do. It was just the term it only was less than a few years old. And a lot of people absolutely believe that this program had knowledge of humans and psychology, and a story which is supposed to be true that his own secretary believed it and started having conversations with it when he wasn't around. And one day he was in the office and they said, "Doctor, will you mind leaving the room? I need to talk to ELIZA." And he goes, "Huh?" So that's now called the ELIZA effect.
Is it? Okay, based off of that. Oh, interesting. I didn't know that. Well, I'll be sure to put links.
And replica is based on the same idea of just echoing back what you said. So it totally panders or utilizes the theory of the mind. So the Turing test is as much about human psychology than not. But to answer your question, yes, that'll happen, and it won't matter. Because we can already be somewhat surprised. I mean, the stuff coming out of GP3 and those big language models, it can easily be mistaken for human speech, but it isn't. It's not even speech. It's just text.
It's just text that it's randomly. Well, not even randomly. I
It's
shouldn't
not
use the
random.
word random.
No, it's very cleverly.
No, it is cleverly designed.
But one insight to that is what machine learning does. Okay, machine learning is statistical, right? It's all about statistics. And so it works well in applications where you have the basic thing that's processing is statistically uniform. Like, that is, each data element can be treated more or less like any other data element with minor variation. So it's good at, say, a pixel array, because pixels are pixels, right? And then you can find patterns in the pixels. Or in plasma particles and fields. They were using it to figure out waves in a tokamak reactor. Because again, you're talking about particles, and particles are particles, right? They're statistically uniform. So if you're going to practice that same technique on something like human language, compendiums of text or databases of text written by humans for humans as language to be decoded in the human brain as language, assuming there was knowledge. Well, you can't do that at that level. It has no access to those higher level encodings. So it basically is looking at things at the statistically uniform level. And what is that? It's ones and zeros. It's down there at the ASCII, ones and zeros of the ASCII encodings of the characters which make up the words which go in the books. So it finds patterns. And it can find this pattern is likely statistically be next to that pattern. So it can come out with statistically likely patterns that look like a human said them, and even causes ideas to come into the mind of a human being who is reading text that was never written. That is language that was never created as a process of articulation. It was created statistically. And that's why machine learning, all this, negative stuff, because they're trying to make decisions about people based on statistics. Very low level statistics, and that's not good.
Sure. I was looking back at Bloom's taxonomy. Yeah, I mean, the top level here is to create, I think you mentioned, produce new or original work. And so we'll get there. But at the end of the day, like you said, it's still just zeros and ones. It's just an algorithm that's being run against it.
Well, machine learning is.
Machine learning is.
But we're not doing that in our technology, because even though at the lowest level in computers we have ones and zero, we are going through all the translation levels from symbols to the thing represented, from the thing represented to the knowledge itself. It's layered. It's layer after layer after layer. In our neurons, you can make that analogy that they're like circuits in a computer, and that's not wrong, although the artificial neural networks are they're very crude compared to the complexity of a human neuron. But you can make that as an analogy, and it's not wrong. And so, yes, human beings have a neural network, and we have abstract knowledge and ideas, but layer after layer after layer of processing is between us and the firing of synapses. And to recreate that in an artificial neural network is you're going to have to recapitulate how many million years of cognitive evolution in the human brain? You'd have to know what all that was and what all those layers was, and there's no roadmap to doing that.
Yeah.
It's hopeless.
Yeah, sure. And they've been able to succeed in very narrow areas in this space, right? I think about like learning chess or learning Go, right? I think I read that, they were able to essentially teach, Deep Blue how to play these games, the entire chess in hours.
But you're comparing results. You're not comparing processes. It's not really the same game. Human beings are playing a game designed to teach them to be better at strategy. The computer doesn't have any goal. Its just goal is to make this come out this way, And so, yeah, they can come up with results that are better. If the result is to create a paragraph that sounds more grammatically correct and with robust vocabulary than somebody with English as a second language can do, you could say, well, they had success. Except it's meaningless because there's no communication there. I think at best these language models have some utility as grammar checkers or style. But again, since it's statistically that comes out at the top of the bell curve, it's only going to give you the statistical mediocre, it's not going to be anything exciting or creative or brilliant.
No, that's true. That's what I'm saying. I use Grammarly. I found it to be very useful, to be honest. It's just, you're right. It's a very, very powerful spell checker, even beyond spelling, it misses my periods and commas. And actually, there versus there, I mean, there's some contextual things that it's picking up, right? So, but you're right. It's not creative anything.
That's good. That's good. I have no problem with these things at all. If you say you wrote something and then you ran it through a GPT-3 thing and it came back and said, yeah, those are my ideas, but even better than they were. It smoothed it out. And especially if English was a second language to you. I get that. But you have to say, that's still my idea. Or if it's not idea, what is it? Oh, that's what I meant to say. Maybe that's even better. If so, that's a random occurrence. And it's dangerous, though, and pernicious when people don't understand. The people have to understand that it doesn't. And because it doesn't, there's no guarantee of some egregious mistake. And people have not gotten loans or been arrested and all kinds of other things because of some machine algorithm has been put in a job that requires human understanding without having any.
Yes, fascinating stuff.
So I appreciate the opportunity to talk today and to reach out to your audience because these are things that need to be said over and above the excitement that we have about what we've created, which we think is going to realize all these things that we've been hoping were going to come, but thought maybe they weren't, still decades away.
Yeah, sure. They're coming faster than we think.
Before you know it, you're going to have an opportunity to talk with a non-human entity that understands your language.
That'll be awesome. That'll be awesome. Well, great. Well, that was our point to hear of this podcast here is doing applied artificial intelligence. So this is right in the whole application space. How should people reach out to you? Obviously they can check out newsapiens.com, I'm assuming, right?
Yes, please do. And there's also another website that we've recently set up focused particularly on the coming companion sapiens. And that's called My Sapiens. And I also have a blog site I use when I talk about things more generally. It's called Forward to the Future.
Forward to the Future. All right. Well, I'll be sure to include that stuff in the liner notes for sure on this. Get the word out. Yeah, this third wave of AI is very, very interesting. I'm excited to see where it takes us. Was there anything else you wanted to mention here or any other topics or projects that I missed?
I think we've really kind of covered the waterfront. Forgive me for monopolizing the conversation.
No. I'm here just to essentially provide the platform here to have people talk about what they're doing. Just provide a way for people to see what's going on in this new fascinating space of artificial intelligence. So appreciate your time again, Bryant, today. Thank you so much for being on the program and look forward to keeping in touch in the future.
Thank you, Justin. It's my pleasure and looking forward to being in touch.
You've listened to another episode of the Conversations on Applied AI podcast. We hope you are eager to learn more about applying artificial intelligence and deep learning within your organization. You can visit us at appliedai.mn to keep up to date on our events and connect with our amazing community. Please don't hesitate to reach out to Justin at appliedai.mn if you are interested in participating in a future episode. Thank you for listening.